Good morning, students. Today we are going to discuss another very important topic of your class 11 syllabus after the chapter of sets, that is relations and functions. See children, there is a very important thing to understand, the difference between a relation and a function. Understood? So, I have kept a comparative study about the definition of relation and functions. First of all, whom do we call a relation? Okay, so relation can occur between not only two people, to like students and teachers, the manual relationship, but also it can occur between the numbers. Say for example, I can say about 2 and 4 that square of 2 is 4 or square root of 4 is 2. Understood? So this is also kind of relation. Like I can say that you all are my students and I'm your teacher. So this is a relation, this is a bonding created between you and me. So such type of bondings are even created between the numbers also, which we called as mapping, which is represented by arrow diagrams. Okay, so about mapping, I think we have already delivered you like notes on that. You have studied about the pictorial representations also in relations, but I would like to again tell you something about that mapping, and it will help me to describe the difference between and elaboration on the definitions of relations and functions. So let's do that. Okay, now see a relation. You have studied about the Cartesian product set. What do you mean by relation? A relation is nothing but a subset of Cartesian product set. A Cartesian product set consists of all ordered pairs. Understood? So what type of relation is created between those ordered pairs? So they have we have taken certain example. Say this is x and the rule which is running here, this is x square. So what is this and what is this? This is, you can see this is an arrow diagram. It's a mapping I have drawn between x and x square. So the rule plays is x square. The square of a number will be situated in this part. What is this? This is a particular set A and this is another set B. Okay, so this particular set is known as domain, and this particular set on the right hand side I have written is known as codomain. Now what about range? This is A domain, this is B codomain. What about range? So range is another very important thing to understand. Okay, so what do we mean by range? Range are the set, all the collection of images. Understood? Range is nothing but image set. What do we understand by image set? Say for example, this particular x is taken from all real number set, and this x square, this codomain set is also a real number set. Understood? So I have given you certain examples that 1 will be running to 1 in the codomain set. -1 will be running to 1 in the codomain set. Okay, so image of 1 and -1 both coincide at 1. Similarly, images of 2 and -2 will be also coinciding at 4. Understood? So, do you feel that the images are not all consisting of the R? The images are of special type? Yes, I do feel so. That is, all the images will be positive numbers, isn't it? So here it is a real number. Real number is collection of all set of numbers. Like you have positive numbers, have negative numbers. Say if it is root 2, it is going to 2, and if it is plus minus root 2, this is also going to 2 only. Understood? So we can say the image set is nothing but collection of all positive real numbers. That is R positive. So I would like to tell you the difference between the codomain and range. Codomain is collection of all the second set, that is B. But range is what? Range is something different. Here range is nothing but the image set. Image set means what? Set of all images. That means in this particular first case, it is R positive. In the first case, it is R positive. Now, I would like to tell you about the second rule I have written here. That is a square root rule. A square root function is there. Function later on I will discuss how it is a function or not. So, here it is also all real numbers I do have. Now, 4 is delivering me two answers, that is 2 and minus 2, and 1 is delivering me the one answer, that is 1 and minus 1. Okay, so like that I can find out the square root of the numbers. What about the square root of the negative numbers, by the way? Does not exist in the real valued functions. Yes, it does exist. You would say, ma'am, we have an imaginary number. So that is not applicable in the case of real valued function. Please do remember that one. Okay, so this is all about the domain, codomain and range. So I will remember domain is collection of all the first elements. Codomain is all second elements. Okay, that is here. And the range is nothing but a subset of the codomain set. So in this case, the codomain set is capital R. So range is a subset of, maybe sometimes equals to codomain set. Okay, suppose here codomain only I have taken R positive, then range and codomain are same here, but every time this is not happening. Understood? So we will discuss later on about the domain and range and codomain. But what about the definition of a function? You can see here I have written something, that is, a function is a special kind of relation. So all relations are not functions. So what is a function? It is coming out from the definition of relations only. And we are not here to accept all relations we are going to create between two numbers, between two sets as function. So this particular designation of a relation function is given on the basis of a very important, or based on two very, if I'm going to split the parts, two very most important criteria. So what are those criteria? The first criteria for a function to be a relation is all domain elements. What I said, all domain elements must have a unique image, or image first of all. That means if I'm going to write down that this is a set A and this is a set B, if there are 1000 infinite also elements in set A, these are domain elements, I must have a image in the codomain set B. Understood? Next thing, there is a line which is written unique, a word which is written unique. What do you mean by unique? That means it is possible that two domain elements are running to one element in the codomain set. That is, the image of these two dots are same. That is this particular thing. Understood? Say it is 1, it is 2. Both of them are giving the image as A. Correct? That is possible. But this is not possible. This is not a function. See very carefully what I want to say here. First of all, what I asked you, what about the square root of a negative number, say minus 1. So you have also understood that in the real valued function, that square root of negative number does not exist. Okay, that is, we are not studying about the complex number system. So first of all, relation is said to be a function if all the domain elements are having image. So first criteria is not done here. It is not obeying the first criteria. So for that cause, we will say the square root function is not a square root relation is not a function here. Secondly, I will say this 4 is running to two numbers in the codomain set. 4, square root of 4 is plus minus 2. So I am getting double answer, double images. Okay, so that is not possible because I need to see the second criteria, that all images should be unique. What do you mean by unique? That means there should be a unique relation, unique image. That is, it may happen that f of a is going to be and f of c is also going to be. That is possible here. But what is not possible? That f of a is delivering me double answers. This is very important. Okay, it is giving me b as well as minus b, or b or c, both of it. That is not possible. So I hope the criteria for a relation to be a function is understood to all of you. This is important, and this is going to be there again in your class 12 syllabus also, students. Okay, so remember that one. Now I would like to tell you about one thing I was talking about, that the square root, I just now said you have studied square root as a function, but why I am not going to accept this one as a function here in the definition wise. Okay, then how it is? It is possible whenever we are going to manipulate the domain and codomain set. How it is done? Let's see. See, for example, if there is minus 1, I am not going to get an image. And definitely if this is 4, I am going to get 2 images, which is also putting me down. Or because of this only, a relation square root is not a function. So why not to change the criteria from RR to R positive to R positive? What do we mean by that? So if I am not going to accept these elements, the negative numbers in the particular domain set, then I don't have to worry about whether this particular negative elements are going to have images or not. Am I clear? First of all, so I rejected all the negative numbers, made it positive. The domain is made positive. Secondly, if such is the thing, and I am going to change even the codomain to R positive also. So 4, definitely the square root of 4 definitely gives me a negative answer. But if it doesn't have a part to be related in the codomain set, whom it is going to be attached? Nobody. So it will only run to the positive numbers. Am I clear, children? So square root is a function whenever it is from R positive to R positive, otherwise not. Similarly, you will notice that a reciprocal relation, understood? A reciprocal relation, only at one point it is discontinuous. And what is that point? That is 0. And you may notice that in the reciprocal relation, always a comma is there and x not equals to 0 word is, expression is written. So what for? Because it is designated as function. It is designated as function, but with a condition that the domain is not accepting 0. Other than 0, all the real numbers are going to have image, and not only that, it is maintaining this another second criteria also, it is unique also. Okay, students, so you please go through the theory part of relation and function. That is very important. After that, I was talking about the domain, range, and all this codomain, everything. So the another important questions, or another set of questions you will be getting from in your half-yearly exam, which is from the domain and range. That means a question will come that find out the domain and range of certain functions. Please have a look on these functions. I have written few functions in front of you, and we will be discussing verbally about the domain and range of this type of functions. Okay, here they will say these are all real valued function, but we do have certain limitations on the range and what type of outputs are there whenever certain inputs are being fed. That is from real numbers. When we are getting real numbers inside them, how the output, how the image set is going to come out from there. Okay. Now, let us understand that what is domain of this symbol is domain of f. And I am considering they are all real valued functions. Remember children, what is the meaning of real valued functions? When we are talking about all the real numbers in the codomain and domain set. Okay, all domain and codomain and range, everything is subset of what? Subset of real numbers. Remember that one. Now this is the first one, that is a modulus function. So this is the definition of the modulus function. Mod x is x whenever x is greater than equals to 0, and mod x is minus x whenever we are in the negative number line, that is x less than 0. That is the only reason and the very important property of an absolute function or modulus function. Understood children? So what we know from a definition of modulus function, always we are going to get the what? Yes, the positive answers out of it. Whenever we are going to insert the real numbers, whatever kind of real numbers, we are going to get only positive real numbers. So about it, I would say, then the domain, if the domain is real number set, the domain of mod function is real number set, then the answer, that is the image set, is always positive. So I would write here, I am going to write here, DF means domain of real number, this particular thing, and range is all R plus. Is it okay? Now this is what function? This is known as signum function. See here children, this is known as signum function. Okay, so by definition of signum function, this is 1, 0, minus 1. Why this is so? The reason behind it, that mod function is there in the numerator. So imagine whenever we are in the positive number line, so x by x is 1. Whenever we are in the negative number line, it is minus 1 by 1, that is minus 1. And the assumed value at x is equals to 0 is 0. You will really think about it, that why this is 0, because it should be 0 by 0 and undefined 1. Okay, so you all know that if the one element in the domain set is left out without any image in the codomain real number set, what will happen? It will lose the designation of a function. So what they have done, it is defined in a way that for 0, it is 0 only. Understood? For 0, it is 0 only. Now you can very well define the domain. Domain, all the real numbers are domain here. And you can very well define the range also just by looking into the answer. That is, we are getting the three elements in the image set. That is, the range is 1, 0, minus 1. So how the graph is also looking like? It is continuously 1, okay, it is continuously minus 1 depending on the positive real number line and negative real number line, and at 0, it is definitely 0. Understood children? Okay, after that, here I have written what? The greatest integer function. This is what? The greatest integer function. It is even known as box function based on the symbol. See, you can see there is a box inside it, there is an x. Okay, it is even known as flow function. Okay, so what is the behavior of a greatest integer function? What it does? What a greatest integer function does? Its action play occurs whenever we are putting inside the box function any non-integral value. It converts, a box function converts all the non-integral values to integers. So what about the integers if it is feeded? If you are going to feed an integer, it will come out the same only. Okay. It will behave in that case as identity function. Now, the very good question comes, and what will be the value of this one? This will be 1. But why it is? So, greatest integer function sees that where 1.1 is lying, 1.1 is in between two integers, that is 1 and 2. Understood, children? Now, within this interval 1.1, 1.2, 1.9, everything is lying, which are not integers. Now, what will be the answer? No, I said 1. Why? That means the smaller integer. Out of these two, what is the smaller integer? It is 1. So, for greatest integer function, we have to substitute the smaller value of the integer. Understood? But what about the smallest integer function? The smallest integer function has a symbol of this. So, in this case, for the smallest integer function, the answer will be 2. That is the higher value of the integer. That is for 1.1 box, it is 2 in this case. I hope you will always remember this one. And you may go through the theory portions. I will be even sending some of it. And you do have the same in your book also. It is very important for not only your class 11, but also the definition is very much required for limits and your derivatives and in your class 12, because you're beginning with relation and function in class 12. Understood, children? Now, what about the domain then of the greatest integer function? Domain, we are accepting all real numbers. There is no problem with that. Now, what about the range then? Only the integers. I hope this is understood, students. Remember, only the integers are going to be the answer. Okay. So, the codomain. Codomain is all real number, but the domain is R and it is moving to only answers of integers. Understood? Very important function is this. Understood? So now trigonometric function, I have chosen just one trigonometric function. Say sin x. Here the domain is all real numbers and the range of sine function, as you have already studied the same in your trigonometric function chapter, the range of sin x is from -1 to closed interval -1 to +1. Understood? So whatever x is there, whatever the value of theta is here, we are always getting the higher value. The highest one is 1 and the lowest value is -1. Remember, child. Okay. Now x square plus 1. This is also understood. There is a square function. So the answers are always positive. So domain can be any real number. Don't have a problem with that. But what about the range? Let's calculate the range of x square plus 1. Okay, for this function, we all know that x square is always positive. X square is always greater than equals to 0. Now, but we have here x square plus 1. What to do about it? Let us add 1 on both sides. Let us add 1 on both sides. Do you understand what I am doing? I am going to I'm finding here the range. That is, the values will be from closed interval 1 to infinity. Closed interval 1 to infinity. So this is the range. Am I clear, children? So this is what I discussed in front of you about the domain and range of certain important function. Now, in some cases, you may have reciprocal functions also like this, where you have to find out the domain of this one. Remember, for whenever you are having a reciprocal function, for domain, you have to remember we cannot accept those values of x for which my fx goes absurd. That is, x plus 7 should not be 0, x should not be minus 7. Understood? Now, if it is a square root over here, then in this type of questions, you must remember when the denominator contains a square root also, then we have to remember under the square root for real values of fx, we should not get anything negative. That is, x plus 7 should be greater than 0. And we cannot make it equal to 0 because it is in the denominator. Remember this one. Otherwise, it is okay. So, in this case, the domain will be what? From minus 7 to infinity. Okay. Because it is greater than minus 7. So, this is how we used to calculate. We have to learn all these definitions of the functions, the famous functions I discussed today, and the domain and range problems are even important. Okay, another one more problem I would like to discuss. Say, this is a function you are having here. Say, for example, 25 minus x square. Okay, so this is. So what I said, if you want to calculate the domain, so you must remember this should be greater than equals to 0. Understood? So I have put a equals to because it is not in the denominator first of all. I can write even. Okay, so x minus 5, x plus 5 less than equals to 0. Now on the real number line, we can have an observation of this particular function, the behavior of the particular function. For that, what we will do, we will find out the zeros, of your quadratic inequality. See, so what are the zeros? It is minus 5, it is plus 5. Now, this entire number line is now split it into 3 intervals. I hope you all understand. We split it into how many intervals? 3 intervals. 1, 2 and 3. Now, assume any interval of your choice. Say my choice is second. Your choice can be third or fourth. Understood? So, I am choosing second interval. In second interval, randomly choose any numbers. I am choosing 0. You may choose 4. You may choose minus 4. You may choose 6. You may choose minus 10. It's up to you. Okay. So, I am choosing 0 and I am feeding the 0 and calculating orally that what will be the value. It is a positive or a negative value. So, imagine 0 minus 5, 0 plus 5. It is giving negative answer. What it is giving? Negative answer. So, the second interval is giving you negative answers. Okay. Then the alternative. There is a alternative flow of the signs. Whenever the middle one is negative and the sides will become positive. Say I am starting with the first interval. If this first interval comes negative, then the next will be positive, then the next will be negative. Alternatively, the signs are going to change. Understood? This type of points are known as critical points. Okay. Why? Because whenever a function jump across the critical points, it is going to change its sign from positive to negative or negative to positive. Am I clear, children? This is a very important thing. We will study more in linear inequalities also. But now it is required. That's why I discussed with you. Okay. So, in this case, I have come to know about a detailing of this function, this polynomial, this quadratic polynomial throughout the number line. That is, it is positive in the first one, negative in the second one, positive in the third one. What do I need here? We need a negative answer. Okay. When it is negative, in this particular interval, it is negative. So, the domain. So, in this case, the domain or the x must belong to minus 5, that is closed interval minus 5 to closed interval plus 5. So, this is my domain. This is my domain. Okay. But whenever we are going to find out the range of this particular function, remember children, y is root over of 25 minus x square. Whenever we are dealing with the second part, that is the codomain and range, we must put this x in terms of y. This is a special relation. Here, I need not to work out a mode. That is, I can change x in terms of y very quickly. So, this one is not the same in every time. You have to calculate the value of that. Now, for this one, again the same thing flows. I must see for a real value of this x, this particular thing should be greater than equals to 0. And in the same way in the number line, I am going to have the same answer of -5 to +5. Now, I need to tell you one thing about here. Children, this cannot be the range. Why? The range cannot be -5 to +5. You know why? Because of the same square root problem we faced in while doing the definition of this one. What is the problem we faced there? That one number cannot be related to 2. So, based on the definition of that, we must remember here that a particular number cannot deliver here 2 images. We cannot, it cannot deliver 2 images. Okay, why this is so? Because it is not then following the rule of a relation to be a function. So in this case, what I am going to do? I am going to cut off the negative set of numbers from here, because here you know that the domain is only -5 to +5. Understood? So in this case, it should be only 0 to 5. Otherwise, what will happen? Otherwise, what is going to happen? Suppose if x is 0, then it is going to deliver +5 and -5. At 0, it is going to move to +5 and -5, which is definitely making it not a function. Okay, so we have to remember that whenever we are putting the last answer, we must see whether it is satisfying the relation or not. Okay, so this is all about the domain range, or finding domain range of a function. Starting from the definition to here, it was a quick summary of the entire thing. So I hope it is understood. You please do follow the notes and the problems. We will be providing it to you, and definitely practice well. All the best wishes for your upcoming examination. Once more, I am saying this to you. Okay, have a good day.